Good afternoon, everyone. I'm Dr. Shikhar Tyagi. In the previous lectures, we discussed about the principal component analysis and its R programming. Today, we are going to talk about the factor analysis and its visualization and computation through the R programming language. All right. So, before going to start, I am going to provide you some basic codings for the visualization of factor analysis. So for the factor analysis, we are going to use the package ggplot2 for the graphical representation. And for the factor analysis, we are going to use the facto extra package in R software. We already installed it in the R. In that case, the first plot that we are going to show that is the script plot with percentage labels. So for that one, the command is fig underscore eig. All right. So this command draws the script plot which shows the eigenvalue or explained variance of each principal component. So this is a function that we use to visualize the eigenvalues. It helps us to see how much variation each component explain. So inside this command, we just introduce few syntax. So first is PCA here. So PCA we use. So this is the PCA object that you created earlier. We create in the beginning. All right. Usually the function like from the functions like PR comp. All right. As we have heard earlier here, PR comp earlier for the PCA analysis. So we use this type of principal component analysis here. All right. And add labels equals to true. Okay. So in this one, before that one, PCA contains the eigenvalues, principal components, explained variance, loadings, and scores. So PCA is the main input data structure here in this side inside this command. After that, we have the add labels that is equals to true. It means the labels will be adds on the plot. True means it should show the labels. These labels usually shows the percentage of the variance explained by each component so that the bars in the script plot will not be blank. They will have numerical values on the top. And after that, we have the y limit equals to c combined 0 to 50. So this sets the range of the y-axis. Limbs means the y-axis limit. All right. And combined 0 to 50 means that the y-axis will start from the 0 and go up to the 50. All right. That is the first code that we have for the visualization. Second is the FVIZ. Okay, means factor visualization underscore PCA underscore VAR. All right. In this, we have PCA column dot variance. All right, and gradients dot columns. So basically, these commands draw the variable correlation circles, which shows how the variables are related to the principal components. All right. So this command f which underscore PCA underscore variance. So this function visualize the variables in the PCA space. Each variable is usually shown as an arrow. Inside this command, we have the syntax PCA. All right. As well as PCA is same that we have discussed earlier. And after that, we have the call dot variance that is equals to contribute. All right. So this controls how the variables are colored. So call dot var means color the variables according to something, and contrib means color them according to their contribution to the principal components. All right. So variables that contribute more strongly will appear with different colors than the variables with smaller contributions. So gradient dot colors equals to combine, that is blue, yellow, and red. All right. So this gives the color gradients: blue for the low values, yellow for the medium values, and red for the high values. So the plot uses a small transition from the blue to red to represent the contribution level. All right, this is your second graph. Now third graph is f which underscore PCA underscore int. So this commands draw the individual factor map, meaning the plot of observations or data points in the PCA space. So this command f which underscore PCA underscore int, this function visualizes the individuals or the observations. Each point on the graph is one observation from our data set, and PCA is principal component analysis result objects, and color dot independent equals to cos 2. This controls the coloring of the individuals. Col dot int means colors the individuals according to something, and cos 2 means the cosine squared value. All right. The cos 2 values tells us how well the observations is represented on the plot. So high cos 2 equals to basically equals to the point is well represented. Low cos 2 equals to the point is poorly represented. So after that we have the gradients dot colors here. That is, we are going to combine blue, yellow, and red. So blue is basically going to represent the low quality of the representation. Yellow is for the medium, and red for the high quality. So the points are colored depending on how well they are represented by the selected principal components. So this is your this was your fourth individual factor map visualization. Now fourth one is your biplot, that is the combined biplot by using the command f visualization factor analysis visualization underscore PCA underscore biplot. All right. So this command create a biplot which combines both variables and individuals in one graph. So this function shows both observations as a point and variables as an arrow. So you can interpret the relationship between the data points and the variables together. So PCA again we are going to use for the principal component analysis objects, and repel equals to true. This means the labels will be adjusted automatically so they do not overlap too much, and repel controls the label overlapping, and true tells the function to push labels apart. All right. After that, this makes the plot cleaner and easier to read. After that, we have the color dot variables equals to red. All right. So this sets the color of the variables arrow or labels. All variables will appear in the red, and color dot individuals equals to blue. This sets the color of individuals or points. All observations will appear in blue. So this command creates a clean biplot with red variables and blue individuals. All right. So after that we have the fifth command, that is the contribution of the variables to each principal component. So for that one we have the f visualization underscore contribute. All right. So that is your PCA choice equals to variables and access equals to 1. So these commands shows the contributions of the variables to the principal components. So f visualization underscore contribute, this function displays how much each variables contribute to a chosen component. It is usually shown as a bar plot. Okay. So PCA is the principal component object containing the analysis results. A choice equals to variable. So this tells the function what to analyze. So var means variables, and if it were ind, it would means individuals. All right. So access equals to 1, it means we use the first principal component analysis, and access equals to true means we are going to use the second principal component analysis. All right. So that's why first command is for the first principal component and second command is for the second principal component. All right. So this was your basic visualization command for the principal component analysis. All right. All right. So we will discuss the first example for the factor analysis from the correlation matrix. So in this example, we have a matrix R where we have the data set. All right. That is in the form of 1, 0.8, 0.3, 0.2, and so on, where we have defined the number of rows equals to 4. So this is our matrix. All right. So this is our correlation matrix where diagonal correlation is 1 and other correlation between other variables are given. Between 1 and 2 is 0.8, between 1 and 3 is 0.3, between 1 and 4 is 0.2, and so on. After that, we are going to use the factor analysis here. So we are going to check that principal component method. All right. So in that one, we have the command that is fact anal that we are going to run with the covariance matrix equals to R. Factors we are going to consider that is 1, and rotations is none, and number of observations we are going to take equals to 100 here. All right. And we just check the loadings of the our principal components through the factor analysis method. So this will be the output. All right. So for the first factor, the loadings are 0.89, 0.892, the similar 0.306, 0.306. So okay, so the loadings of the factors is 1.780 and the proportion of the variance is 0.445. All right. So fact null performs the maximum likelihood factor analysis, and cov-mat equals to R supplies the correlation matrix. All right. And with the one factor, the loadings are these that we have seen. So variable 1 and 2 have the highest high loadings, and variable 3 and 4 have the moderate loadings, and the factor explain 44.5% of the total variance. And communalities, basically, we will check here with the variance rotation. We will check rotations. Here we just took the none, and here we are going to take the rotation equals to variance maximum. All right. So with this one, we will check the same command. All right. So all the results are similar here, and then we will check the communalities in that one. Okay, so communalities, variable 1 and 2 have the highest communalities, that is approximate 0.796, approximate 80%. It is going to explain. All right. And variable 3 and 4 have the communalities, that is almost approximate to 0.094, almost explain the 9% of the communalities. All right. So this is the first example of your factor analysis, and the remaining examples we will do in the next session. Thank you so much. Subscribe the channel for the further videos. Thank you.